In this chapter, we're going to be studying statistics. In this lesson, we're going to look at data grouped into intervals. And we'll begin with a discussion of class intervals.
Okay, hi everybody. In this lesson, we're going to take a look at, well, when data is grouped into intervals. Okay, you'll see what I mean by here in just a second here. We're going to kind of jump right into an example here. And we're going to build, we're going to look at class intervals and histograms here. So let's assume that the following figures here are the heights to the nearest centimeter of a group of students. Well, what have we got here? We've got 1, 2, 3, then 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. So we've got 36 students there. And now notice that the heights of people in a group are measured to the nearest centimeter. Okay, so anytime we're measuring heights like this, we're gonna, when we look at our measuring device here, we're gonna end up rounding. At some point there's gonna be rounding here. We all know that even though height is gonna be a continuous variable, that it's gonna look as if it's, okay, it's gonna look as if it's discrete data, just because of the way we're going to communicate that data. Okay, but we know that that's just an approximation, that this is actually a continuous number scale. So that's an important understanding in this process. So typically what we're going to do here is take a look at the group here. So these figures do not give us much information about the heights of the people in the group. It helps us to make a frequency table. And in this case, as there are a large number of different heights, it's a good idea to group the heights into categories or classes, okay? And so that's what we're taking a look at here. This is class analysis. So in this case, we're going to make the classes 148 to 150, 151 to 153, and so on before making a tally. And so what I'm going to do here is I'm going to run through this this particular little tally here, and I'll do this. But just take a look here, 148 to 150. Now let's be clear. When we talk about 148 to 150, I'm actually talking about people with a height that's 147.5 centimeters. Up to, but not including, 150.5 centimeters. That's what we mean by that interval right there, is actually going to be this interval here. But those are going to be measured as 148 to 150. So I'm trying to make sure that I've acknowledged the fact that this is actually a continuous variable as I do this. Now I'm going to do the tally right now, and then you'll see the results in just a moment here. Okay, and so now I'm done, and hopefully I did that correctly here. I know that the numbers do match up, okay, but here we go. So now we're going to finish the frequency here. So, and the way we do this here is I'm just going to add up the tally here. So there's 3 there, 8 there, 7, 4, 6, 2, 1, 2, and 3. So there's the frequency. So just to kind of reiterate what's happened here, so each height's recorded in the appropriate row of the tally column, and the first class interval represents all the people with the heights from the range 148 to 150. And again, because this is continuous data and we understand the way this is going to get rounded here, this means that that's going to extend backwards to 147.5 and then up to, but not including, 150.5. Okay, so those are the people that we're including in those categories. Now, in the class 151 to 153, what we're going to end up doing here is we're going to use what we call a class mark to represent that interval. So in a sense, what we're going to do is we're going to assume that all 4 people here, let's say right here, all 4 people there have a height of 158 centimeters. Now that's not true. That's not true. But this just gives us a way of talking about the distribution of heights in that group here. Okay, if you just want to look at the raw data and look at everybody's heights here, well, that's great. But that doesn't really give us a lot of information that's easy to interpret. So what we're trying to do here is take the data and make it easy to interpret so we can maybe notice trends in the data. So what we do is we create this class mark that we're going to use to represent the entire class. And really what it is it's just the upper boundary plus the lower boundary divided by 2. So in other words, if I'm going to work Oh, okay, sorry. Well, that was a little different here, but if you wanted, for the first one there, x1 there would be 147.5 plus 150.5 divided by 2. So the first representative mark would be 149 here. So now what we do is we're going to take all of those class marks plus their frequencies, and we're going to put them in the calculator. And I've already done that into list 1 and list 2, okay? So you can see that those are already in there. And now what we're going to do is we're going to use one variable stats on list 1 and list 2 to find the mean and modal class and standard deviation to 2 decimal places. So that will be stat over to calc, and this is going to be one variable statistics, remember, but we do have a frequency list in list 2. So calculate, okay, and here we go. And so what is the mean of our data? Well, it's 158.3. So the mean is going to be 158, what did they say, to the 2 decimal places, to 33 centimeters. The modal class. Well, the modal class, that's, I don't need the calculator to tell me what that is. I just got to look at the chart here. Which one had the highest frequency? Well, this one right here. So that was 151 to 153, okay? So my modal class was the 151 to 153 centimeters. And we understand that that implies just a little bit beyond that in both directions here. The standard deviation, assuming that this is my population, it's going to be 6.99, okay? The standard deviation is 6.99 centimeters. And remember, what that means is that on average, the distance that a person is away, or the distance that a class here is away from the mean, is about 7 centimeters. Now, one thing before we walk away from this is just note here, and this is important, the calculator should not be used to calculate the medians, because if I do that, I come down to here, I've got a median here at 156.5. At least that's what the calculator's saying here. But we shouldn't be using the calculator for that for continuous grouped data, because it assumes that all values in the class and marks are the same here, and that's not true. And so that really isn't a very trustworthy measure at all. So don't use that to come up with the median. That's not going to be very helpful at all. Okay, now the next thing we want to take a look at here is something called a frequency histogram. And it can be used to represent the distribution of data. It is a bar graph, okay, now, but it isn't, okay? It's going to look like a bar graph, and your immediate response will be, well, it's just a bar graph. But the bars here are different, okay? They're used to represent continuous data, which means that there are no gaps in between the columns or the bars. The bars bump right into each other. With a normal bar graph, what you get typically is something that looks like this, okay? You got a bar there, bar there, bar there, like that. That's your bar graph. But a histogram looks more like this. Because the data is continuous, okay, the bars bump into each other. So there is no gap in between, or if you do see a gap, okay, if you do see a gap like that, that's because the indication there, what this is indicating is that there's no data there in that particular interval. So the boundaries of the frequency columns of the histogram represent the true limits of the data values, the true limits, okay? So what that means is the data point 153 represents a height somewhere in between the 150.5 and the 153.5. So the boundaries for the rectangles here are going to be based on the fact that the data is continuous. And so yeah, that 148 to 151, okay, that is actually going to be the 147.5 to 150.5. Or sorry, this would have been 148 to 150. Okay, 148 to 150 is actually going to be that interval right there, a little bit bigger, and so on. Now, turns out your calculator can actually do this. So first of all, what we do is we enter the data into list 1 and list 2. And fortunately, I have already got the data in list 1 and list 2. Then what we do, and I'm just following along here, I'm going to go second stat plot. So this opens up a menu of statistical plots that the calculator can do here. And what I got to do is just turn this one on. So I'm going to press enter on the stat 1 there. And I'm going to turn that on. And then I want to go down and I want to come over here to that value right there, that image right there, I should say. That one thing they call it glyph. And I want to turn that one on. And what that does is that tells the calculator that we're creating a frequency, sorry, a histogram. Now, my data is in list 1 and the frequency is in list 2. Now, the color here, by the way, doesn't make any difference, so don't worry about that. Now, what we want to do once we've got that entered in is we want the calculator to be able to use our model our data there. So I have to adjust my window settings to fit the data here. My x minimum is going to be 147.5 and our x maximum is 174.5, and that's because I understand how the rounding works. I also understand that for my scale here, each one of those should represent a width of 3. In other words, the x scale here is going to be the width of the rectangle. And that actually makes a lot of sense here. If you just take a quick look at this, 147.5 to 150.5, yeah, that's a width of 3. Now, my y min, well, let's make that -2, just like we're following along here, just so that we can see the minimum there, the bottom of it. And our maximum there, I think our maximum frequency was 8, so we want to make that just a little bit bigger. And our scale can be 1, that's fine. And now when I press graph, oops, I'm just going to press pause right there because I have data in there. Isn't that interesting? So there's my histogram, but there's something else going on here, and this happens frequently. So it's not a bad thing that this happened here. If I press y equals, yeah, I've got data in there. So I'm going to delete that, and now go back, and now it's just the histogram that I want to see. Okay? So our window settings here, we want to make sure that we're using the actual class limit min and the actual class limit maximum, and then the jump in class mark. Okay, this is going to be the x scale. Okay, is the width there. And then here we just want to make sure we have a little bit of room in the top and the bottom to be able to see the data. And now, whoops, flip that over and make sure that everything matches up. Yep. Now, if you press trace, this is kind of a neat little feature. If you press trace here, what that does is it's going to jump from column to column, and it's going to actually give you the frequency right there. I don't know if you can see that, but here on this side, it gives you the interval, the min and the max. Okay, and that changes as we go up, and then it's going to give you the frequency. Okay, the number of times that occurs, which is kind of a useful little feature there. Anyway, so let's take a look at some examples now. Okay, so let's take a look at another example here. We're analyzing a golfer here. So a golfer hit 30 balls in succession with his driver. The distance each ball traveled in meters is recorded below. So here's the data, the raw data, which all on its own actually doesn't help me all that much there because I'm not seeing patterns and stuff like this. I need to organize the data to see the patterns. So the data is considered continuous and should be grouped as shown in the table below. We're going to group the intervals in intervals of 5 meters. But the interval 240 to 245 is going to represent anything greater than 240 but less than 245. So we're not needing to adjust for the rounding here. We're going to let that be the interval. And then we're going to jump in the next section from 245 up to 250. So we're up to but not including the higher end point of that interval there. Okay? So now I'm going to go through and I'm going to take this data and I'm going to put it into here. Now before we do this though, really because I'm going to be looking for the frequency, I need to get the class mark for each one. Now remember, the class mark is going to be about the average of the low end and the high end here, and that's going to end up being a 242.5. Here, on the other end of this is going to end up being 247.5. to 52.5, to 57.5, to 62.5, to 67.5, to 72.5, and 277.5. So here's our class marks. Here are the values that we're going to use to represent this interval. So now just give me a moment here and I'm going to fill in the frequencies. Okay, and there we go. So I've got the class mark in there and I've got the frequency. Now I hope you noticed the little error there. That number right there at the bottom should have been 272.9. The data was all listed here in ascending order, and so that was a typo there. Anyway, so there's our data. So now what we want to do is we're going to go and enter the class mark. Yoink, here's the next page here. We're going to enter the class mark and the frequency in the calculator in list 1 and list 2. And I have already done that. So stat, edit, there's my class mark, there's my frequency. And so now what I want to do is I want to do the one variable statistic calculation. So stat, calc, one variable statistics. And this is actually set up for me because I've done this just recently. So I just wanted to calculate and boom, there's our data. So what are we looking for? Well, we're looking for the mean. Okay, and the mean I can see right here is 261. Okay, we are looking for the standard deviation. Standard deviation is going to be 9.2. Okay, and the modal class. Well, the modal class, once again, that's not really an issue of going to the computer so much as it is just going back to my chart. Which one here has the highest frequency? Well, it's this one right here. So my modal class is the 260 to 265. Okay, so the modal class, okay, was going to be 260 to 265. Whoops, 65. Okay, which was represented, by the way, by our 262.5 meters. So those are the values that we got from the chart here. Now, here we go, quick note. Calculator should not be used to calculate medians because once again, this is continuous data, right? So it's assumed that all the values are class marks and the readings would be inaccurate here. So we can find medians later. We'll show you what to do with your calculator to get the medians if you've got data that's grouped like this. But first of all, let's go back and let's create our histogram. Now you can see it right there, but let's go through and take a quick look at it. So my calculator here is already got the stat plot turned on, and in fact it's all ready for it. It's got the histogram highlighted, list 1, list 2 there. Really what I want to go is to my window settings here and fix that. Well, I know that my low value for the window was going to be 240, and I believe my high value, actually I got to go back to the data there. I don't remember. The high value was supposed to be 280. Yeah, that's what I figured. 280. And our scale here was going to be 5. Now, I think our Y min and our Y max there actually are still going to work here because Y min at -2 will give us just below the graph, and a Y max of 10, well, I think my highest frequency was 7 anyway. So if I press graph, and there it is. And that's actually what you're seeing right here, okay, on the graph that was provided. And once again, if I use my trace button there, I can go from class to class, and it'll tell me not only how what the range is for that particular modal class there, but then I'll also know the frequency that is associated with it. All really good information.